All right, so let's talk about process managers. Why do you think everybody gets so confused about coordinators or process managers or sagas? I mean, I got my ideas, but what do you think?
What I think they are, or why people are confused?
Why do you think people are confused?
Because I think from an implementation point of view, they forget that those are mostly reacting to stuff,
Right.
and that those things can have their own state.
Yes.
And
I think it's because they're so close to the way you build an aggregate or you build a state on an event. And so it gets really confusing is like, what's the difference? And I see people all the time making them way more complicated than they need to be because they like, well, this got to be different than my aggregate. It's got to be something special. And then I see them like building all this stuff to do this and do that. And I've got to add 30 extra events to coordinate all these things. And and all of a sudden they're like, because they just think that they're bigger than they are. And, how do they solve these problems? Right.
Yep. Question is what problem they solve.
Well, so let's talk about the problem. So the problem is, well, if you have everything, if you could do everything, so we write to streams, right? We just talked about the stream database. Generally, when you commit events to a single stream. And that's your guarantee. You can't, in that stream, well, we could give you a distributed transaction. The problem is that if a stream represents an independent piece of processing in your distributed system, starting to build distributed transactions across that starts to lock your whole system together. So both architecturally, by design in most of the stores, and architecturally for good practice in a system, we don't want to start locking more and more things. So we've got one stream that represents the state for effectively one microservice or one aggregate or one whatever we want to do. One processor is going to have a single stream of states that we're going to run through, build up state, answer a question, and then save the result. Sorry about that. And then we're going to save that result. So we build up all the state on one stream, we evaluate something, and then we save the result. But what if we can't answer the question only using the data in the current item? Right? That's the first question. Or what if this is a multi-step process, right? Where I've got to do something to this, so if a user is we're going to create a shopping basket for a user, right? What do I do if the user is disabled and they have an existing shopping basket? If my state is only on the shopping basket, can they check out, right? If all of a sudden we've locked them because they're a suspicious user or their credit card didn't declined, like there's things you can do nowadays on a lot of shopping websites where if you open up the same shopping basket in two different browsers, right, and you add something to the shopping basket while you're checking out, there are edge cases where you can get things in that shopping basket and get them shipped to you that you never paid for.
Someone will notice that.
Yeah. So how do we stop that, right? And how do we deal with a process that moves across multiple things? That's why you need process managers. That's why you need, quote unquote, sagas. Now, I'm going to take a little detour alert. Sagas. Sagas are a term from traditional database terminology that represent a series of reversible, independent database transactions. And I think that they don't have any place in a event-driven world. Because the problem with reversible transactions is that they assume that you can undo something. And in a push-based, event-driven model, you have to assume anything you've ever committed is committed and visible forever. There is only forward. There is no undo, there is only forward. So the way to think about it is not, if something goes wrong, how do I undo all this? The way to think about it is, if something goes wrong, how do I recover going forward? Greg has a great example with, delivering snowplows, right? Because they make a lot of snowballs in Canada, they sell them down in the United States. If I've got a snowplow that's 500 miles away being driven to Detroit, and all of a sudden the deal gets canceled, I can't just, in a database, undo that transaction. Someone's going to step in and decide what to do. Do you put the driver up in a hotel overnight? Maybe you sell it to another city that's already down there. Even if that truck comes back home, odometer is not zero anymore. Something happened to it.
Yep. Interesting enough, because I've been into logistics. They have processes for that. Those are described, and that's the thing. And the thing for the truck is not necessarily that the snowplows are sold, is that the truck arrives at the destination, gets empty, gets full again, and goes to another destination. That's the goal of the truck.
Right. Exactly. So what we really want to think about is, how do we sequence the events to go forward? So the first question we have to ask about process managers is, our commit is on the stream, but we also have a log. And the log represents the ordering between all of our streams. So if I can take my problem and I can move it into one processor, if I can restate the problem so that one processor can answer it, I don't need a process manager. I just have an aggregate.
Yeah, because I share the same log.
Right, I share the same stream. So if I can contain the problem to a single stream, my stream processor, be it aggregate, microservice, whatever, can resolve the problem. And that should be your first stop. My second stop is, I have a coordination problem with more than one stream on the same log, right? And if I have a coordination problem with more than one stream on the same log, what I do is I use the fact that they have a shared log. And I use what's called the write-ahead pattern. And what that means is, rather than saying truck arrived, what I want to do is I want to say truck dispatched to. And the power of truck dispatched to, I dispatch this truck with this contents to this destination. And then I'll have a truck arrived event that I write in the destination, right? Because they're both in the same log, I can now have an external watcher that watches the log. Effectively turns it into what Adam and Adaptive likes to call a to-do list, right? So I know that if I have a truck that left, it should have arrived by Monday. So when I put my truck dispatched, I'll put an expected arrival time on it, right? And then when my arrival time expires, I'll check to see if I have a matching arrival event. So now I can coordinate all these different things by writing down my intent and then having a manager watch this to make sure it happens.
Yep.
And I've had some people say, oh, well, now you have to watch it. Well, you have to watch it anyway. If I build a process manager, what's a process manager doing? It's watching it. And if I build it with this write-ahead pattern, that same watcher can watch for SLA breaches. I can run it on startup. I can run it on recovery. Basically, I can have a constant reconciliation process that alerts me of SLA breaches, does my disaster recovery, does my cold startups, does my failovers, and can always watch to make sure that things are moving according to plan. So now I have one tool and one process that deals with all of these things.
Yep.
It really simplifies it. So that's stage 2. Stage 3 is what I would call a proper process manager. And you need a proper process manager when you don't have a shared log between the two systems you're coordinating. Now, they can be event sourced, they can be event sourced and not event sourced. But here your challenge is I don't have any shared state to watch.
Shared state and shared ordering.
Correct. So I don't have any shared ordering. I don't have any shared state. Just the ordering of the log is my shared state. So with the log, I get shared ordered states, right? So then what I'm going to do is I'm going to use that to create a stream for the process. And it is going to record what's going on. And that's going to be its to-do list. And it can, if it needs to, trigger events and take action. So now we've gone for something that's just watching and taking action on an exception basis to something which can actively manage. It could either be passive or it could be active. That's the other thing people get really wound up about, is they don't understand that a process manager can just be a passive watcher. Just tell someone, hey, something went wrong. You've got to go fix this. Or it can be actively have the logic in it to try and fix and correct things. But those are both different types of process manager. So this one, when I have a kickoff event, I create a new stream. It could be in one of the two systems, or it could be in a third system. And it starts now tracking the process, coordinating and orchestrating between these two systems. And it is its own state, says, here's the history where we are. And again, it leverages this intent.
Yep.
It writes down the intent, this write-ahead log pattern of, I'm requesting this from this system. Okay, I got it back. I'm requesting this over here. I've got a response. And it's internally watching and recording all together. And then your top level is an active process manager that's watching, recording, and then taking action when its SLAs are violated. The other thing that's super powerful in combination with all of these is what I refer to as a later service that allows you to delay send yourself timeout messages. Just delay send any message. But the most effective one to send is a timeout where you send a message back to yourself. Say, at this point, do this. And if that isn't true or something isn't going on, when I get that message back, I just ignore it. But that one externalization allows me to turn all of these timing problems into message sequence problems. And the brilliance of that is now they're all testable. I'm not waiting to try and get this, well, do I need to make this sleep in the unit test for a second to get this to happen after that? I always have a defined order of operations.
Mm-hmm.
I either get a timeout message or I don't before or after this thing.
Yeah. Do you have any typical system you have built? So you have like, okay, I have my stream-based processing, typically an entity.
Yep.
Cross-stream in the same log, and that would be the second one.
The one my go-to when I'm explaining this is generally is order management with trading systems, right? Because you have in large trading warehouses, when different fund managers request, they want to buy IBM, you're running thousands of funds. Lots of different funds might want to buy IBM. And a broker is going to charge you for each one. So what they do is they block the orders together and then they place them with different brokers. And so what you find is you have a stream with the order requests, and then you have a stream with the blocked orders, and then you have streams with the placements. And generally, the orders and the blocked orders are in the same store. But for speed, you generally want a system managing each one of your brokers with a dedicated link to your broker. So the placement with the broker is going to be in a separate store. So use the write-ahead pattern to block orders into a block, and then the block would then do a request placement, which is a write-ahead that gets picked up, sent to another system. A placement gets written there, and then that placement creates a placement request with the broker. Because you have to think about it, you got my block, I got my order request, got my block. Those are together. Placement request. I create a new object to track the placement request, and we don't call it a placement because you're requesting a placement from the broker. You don't know if you're going to get it. And so that's one of the things that you've got to get out of. If you've got something which really isn't going to happen or hasn't happened, write it as a request. The events you want and the objects you want are requests. They aren't completions. And then once you do that, you make that switch, then everything is really simple. So I've requested this, and that will, on the block, requesting a placement of 100 shares will decrement in the block 100 shares. So now, no matter what, those 100 shares are tied up until I get a response to my placement request, which is either placed or rejected or timed out. Right? Does that help?
Yeah, it's clear enough. But the question is, in your experience, how many process managers do you have in the state? Because that's something I got people. How many process managers do you have in the system? How many and what type of process manager? It's like, what is the normal distribution of stuff, which doesn't sense because it's domain related. And
no, it doesn't. I mean, if I've got, so if we talk about instances of things versus no, let me because there is a shape to these things, right? Generally in a domain, I'm going to have no more than 50 aggregates, right? And 50 might be a lot of aggregates, because generally if you get 50 aggregates, you're probably looking at another domain, right? Yep. That's probably too many for one set of thoughts about something. But so for a domain with, like, say, 20 aggregates in it, I might have 2 or 3 process managers.
Yep.
The most, right? And those process managers are going to be on the edges, because generally I'll put the whole domain into one log. So I can use a write-ahead pattern to do all of my inter-aggregate coordination, inter-entity coordination inside the domain. And then it'll be the edges of my domain where I'm talking to another domain or external systems, where I'll have a handful of process managers. And I generally don't lean towards having process managers having their own events and commands. As much as possible, I try and have them use the events and commands of what's going on. And then I add them in as needed. They will have their own, but I don't build a whole new schema for them, right? They respond to things that are happening in the aggregates and inside, and then they create public-facing things and consume them on the outside. Does that help?
Yep.
Yeah.
Giving some kind of broad.
Right now, though, sometimes I put a process manager inside the domain because that process is part of the domain. Now, that's a more advanced case. But something like where you're talking about routing, like in transportation, very often that shipment routing process is the domain logic. The domain logic isn't in the pallet. It isn't in the ship. It isn't in the port. Right? It really is the journey. But there it's a little weird. Like, do I have a journey aggregate? Very often, if I have a journey aggregate, then that is my effective process manager. Right? So, clear as mud again. I think we went all the way around from confusing to clear back to confusing. So
No, I don't think so. No, we're back that it depends on I hate that word. It's how you look at it.
Right.
And what it does that defines what it is.
So, but step one is use the write-ahead pattern in a shared log to drive things into the entity or the aggregate or the microservice. That's one. Two, if you have to coordinate between different entities in your domain, use a write-ahead pattern and a watcher, right, to just coordinate multi-step processes across different aggregates. That's going to solve most of your problems. If you then need to connect to something outside of your domain, put a process manager at the edge of your domain to connect the inside of your domain to your external systems. If the process is a logical construct in your domain, consider modeling it either as an aggregate or as a process manager. And they are really just different ways to do the same thing, because in that case, they have their own stream that manages their state, and they have a life cycle, and they meet all of the definitions of an entity. The only difference is they're allowed to send commands or to send messages out, where a classic entity is always just receiving and raising on itself. Some entities publish things, but if you do it in the write-ahead pattern, you can still write those things as requests that have occurred. And by writing them as requests that have occurred on the stream that you're in, you are now managing a process.
Yep, that's cool. Thank you.
Right.
Thank you.